Back in 2006, the mathematician and data scientist Clive Humby coined the phrase, data is the new oil. And this phrase gained popularity in 2017 when The Economist ran an article with the headline, The World's Most Valuable Resource is No Longer Oil, but Data. In this lecture, I'll investigate what that means and the ways that this is and isn't a good metaphor. But before we get to the side of data, it's worth thinking about what oil is and why it was chosen for this metaphor. If you look at various lists of the most traded commodities in the world, you'll see that petroleum or oil is actually still at the top. In fact, often it takes two of the slots. Although people sometimes talk about oil as black gold, and gold is also on these lists, it's worth thinking about why that is a bad metaphor, why oil is more important than gold and has been so important for so long, and how data might or might not be comparable. One thing to notice, out of all the items on all of these lists, oil is the only one that's strategically important enough that many wars are said to be about it in recent years. Why is oil so much more important than all the others, including gold? It's not just because of any unusual concentration of its production. Brazil actually controls a higher percentage of coffee exports and of soy exports than the Middle East does of oil. The strategic importance of oil is based on what it is actually used for. So in the 1830s, petroleum was just an obscure geological feature of some places. It bubbled up at the surface, and various people over the course of history had made some minor uses for it. But in the 1850s, there was a major development when the Canadian geologist Abraham Gessner discovered how to refine oil into kerosene, which turned out to be a better source of lighting than anything else. At the time, actually, whale oil had been the main source of lighting, and so this discovery of oil refinement may actually have saved the whales. But at any rate, this refinement of petroleum into kerosene led to profitable oil wells starting in several places. And once oil was being extracted and refined for this use, its byproducts started developing uses as well. For a while, these were mostly things like lubrication and heating, but in the 1880s, it turned out one of the byproducts was relevant to this new invention by Carl Benz and Gottlieb Daimler, the automobile. And then soon afterwards, in the 1890s, Rudolf Diesel invented another type of engine that used a similar kind of oil that turned out to be more efficient than coal for trains and ships. And then soon afterwards, Orville and Wilbur Wright figured out how to use it to power a flying machine. Suddenly, petroleum wasn't just useful for light and heat. It became the fundamental way that goods and people were shipped for any purpose. By the middle of the 20th century, petroleum was powering the machines of the world wars, and petroleum was also powering the economic recoveries that happened in the decades after the war. And when I say economic activities here, I don't just mean corporate activities done for monetary gain. I mean any sort of human activity that people care about. In the late 20th century, if you wanted to visit family, go on a family trip, paint a mural, get your band together to play a free concert, bring together political activists for a protest, almost certainly the way that those people were getting to those activities was on planes or trains or ships or automobiles or other devices powered by petroleum. And so the essential features of oil for its strategic importance are these. There was an initial use, lighting, that created the market, made it valuable to start collecting and refining oil. And then once this market existed, a new use was developed for transportation that turned out to be central to huge numbers of valuable processes, and nothing else could compete with it. There was some amount of electric transportation, but only in the most valuable transportation corridors. There were enough sources of oil around the world to keep prices low enough that people were willing to burn it for this sort of use. No one made a gold-powered automobile, and if they did, it wouldn't have sold. But nevertheless, even though oil was relatively abundant, it was still scarce enough that the places with the biggest oil resources remained strategic. And then refinement really was essential to oil to make it valuable and to make it useful. But the different sources of oil around the world were similar enough that they could mostly be refined into similar products and then traded interchangeably around the world. So now let's consider the history of data. In the 1990s, as the internet was developing, search engines sprung up to allow people to find pages that contained particular words. Here are some of the important search engines in the mid-1990s. Then there was a major breakthrough in 1998 when a particular research project at Stanford figured out how to not just look at all the pages and see which ones had certain words on it. That, which all these other search engines were doing, turned out to be easily gamed by people who put lots of random words at the bottom of their page. But instead, this research project at Stanford figured out which pages were more authoritative by seeing which pages were linked to by others and giving more weight to the links that came from pages that were themselves authoritative. One of the designers of the algorithm was named Larry Page, and the ranking was called PageRank as a result. And the company that he and Sergey Brin founded was called Google. So in the early days of the web, many websites funded themselves by running ads at the top, the same way that newspapers and TV shows and bus stops did. You can see some ads on these Lycos and Yahoo pages here. Advertisers knew how many people were loading the pages that contained the ads, but they didn't know much else about the viewers, just like viewers of a magazine or a bus stop. At first, Google specifically didn't run any ads, but a few years after they started, they did start putting ads in the search results. And in particular, they did this aimed with a little bit of extra information. Namely, they knew what the person was searching for. And with this information, they could better target ads to people while they were looking for information about something. This made the ads more helpful both to the seller of the ad or the purchaser of the ad, the corporation that wanted to sell something to people, and to the viewer of the ad, the person who was searching for something. Furthermore, Google had an advantage over many earlier forms of advertising in that they could tell not only what you were searching for, but whether you clicked on the ad that they showed you. And so at first, they used this to charge advertisers only per click that people made rather than per view. And then they realized internally they could use this information to choose to display the ads that got the most clicks so that Google got the most payment and the companies got the most customers. Very quickly, Google was making so much more profit off of its ads based on this better targeting that in 2003, they launched this program called AdSense, which other websites could contract with so that Google would provide ads on the other website, not just on their own. That meant that these other pages could get more profitable ads because they were powered by Google's information. And Google got more profit because they could take a small cut of the payment collected for all the ads on these other pages. However, the most important thing for Google is they now got data about who was clicking on ads, not just on the search pages, but on all these other pages on the web. And that gave them much more information about how people were interacting with ads and enabled them to get even better at targeting ads. And so with this initial use of data based on associations between clicks, search terms, websites, and ad contact, Google showed other companies how valuable data gathered just automatically from the web could be. Other companies started taking similar advantage of data that they had. News story. Soon after the DVD was released in 1996, a small company took advantage of the small size of DVDs to do mail order rental rather than in-store rental like was happening with VHS tapes. They had an internet site where people could list the queue of movies they wanted to watch, so they named themselves Netflix. They didn't yet do the viewing on the net, they just had the queue on the net and you would get the discs in the mail. Netflix was able to be profitable within just a couple years, but by 2006, it became obvious to them that a change was coming. There was a small company called YouTube that had been founded in 2005 and allowed people to watch video directly on the internet. And it was very quickly gaining users, and in fact had gained so many users that within a year, Google bought it for over $1 billion, which was one of the hugest internet acquisitions up to that point. Netflix realized they were going to have to move to streaming as well. And during the DVD days, they realized they could profit by people putting on the list movies that they thought they should watch, but then they would often just leave the disc on top of their TV for weeks before they finally got around to watching it. The same way that people would buy gym memberships thinking, I really should go to the gym, but then never use them. However, once they got to streaming, Netflix knew they were going to have to keep people's interest by giving them movies they actually would watch rather than just keep profiting off of them having the subscription. And so they knew some simple things, like people who liked horror movies might want more horror movies, and people who liked comedies might want more comedies. But they realized they had a lot more specific information than just that. Each of their hundreds of thousands of users had rated dozens of the tens of thousands of films that Netflix had. And they realized this could be useful for figuring out if there were any surprising connections between movies or between customers. And at first, they were just using that data internally. But in 2006, they specifically made an anonymized subset of this data public and offered $1 million prize for any team that was able to come up with a way to use this data to design an algorithm that would be 10% better than Netflix at recommending movies to users. They also required that the top teams publish their research and license it to Netflix, but they would be allowed to use their research and this data in any way they want. There were a whole bunch of teams that entered, including some from various universities like Toronto and Princeton. Eventually, several of those teams merged and the prize was won in 2009. But there were a bunch of advances made by a bunch of different teams along the way. Netflix was able to make the transition from DVDs to streaming and quickly showed that the value of the data that they were getting from users incidentally. And the research published by these teams gave other companies a start for ideas on how to use their own data. In 2010, Netflix was going to start a second prize to call for improvements even over this new algorithm, but a team from the University of Texas had noticed that by using the anonymized data in the initial Netflix prize and comparing it to data that people had used on IMDb of their own ratings of movies, they were able to identify these anonymized users. And so in one stroke, this competition had shown the value of data for improving computer services and shown the risk of the public display of user data, and also developed several of the techniques that would turn out to become more powerful for both of these applications in coming years. A few years later, there was another major public challenge. This one was run out of Stanford University, run by the researcher Fei-Fei Li. She had gathered millions of images and paid people on the internet to tag them with a few thousand different terms that were nested. Things like dog or corgi or battleship or ship or strawberry. And in the first few years, she had been asking for people to come up with algorithms to automatically tag these images and use this trained data from humans to do so. And there were a bunch of teams that entered in these first few years, getting up to something like 75% accuracy, which is really remarkable given that there were thousands of different categories and that they had to be able to tell not just dog from cat, but corgi from Shiba Inu and so on. However, in 2012, one of the teams that had been an early leader in the Netflix prize, run by University of Toronto researcher Geoffrey Hinton, who had been one of the initial proponents of backpropagation as a neural net training algorithm in the 1980s, together with two of his grad students from Russia and the Ukraine, Alex Krzyzewski and Ilya Sutskever. This team developed a neural net-based system called AlexNet that turned out to do so much better than everyone else. It reached 85% accuracy. And all the other teams up until this point had been using more traditional symbolic AI processes. But this one showed that the neural net was able to not just compete, but do much better. Furthermore, the neural net structure made it clear no new essential creativity was going to be needed to improve this. All that was going to be needed was more computing power and more training data. And this started a major race. Companies that had access to consumer data realized they were sitting on a gold mine or an oil well. Grocery stores could track which customers bought what products when. And this would allow them not just to do efficient shelf stocking, but they also realized they could figure out when a customer was pregnant and start sending her ads for maternity goods. Photo sharing sites like Flickr realized not only could they provide a service to the customer, they could use their data to train image recognizers and thus also train things like self-driving cars and drones. Social media companies realized all the user sentiment data that they had would be useful not just for targeting ads, but also for influencing social sentiment and even elections, became clear in elections throughout the mid to late 2010s. Every single piece of text on the internet became valuable as a way to train large language models. In 2006, when Clive Humby said data is the new oil, all that he was noticing was data is valuable, but it needs to be refined in order to be useful. However, by 2017, when The Economist said it was now the most valuable commodity, it had developed many new uses, many of which were strategically significant, as self-driving vehicles and election influence make clear. So now let's compare data to oil. So the essential features of oil were these, that there was an initial use that made it valuable to start collecting it. And for data, this was advertising, like what Google was doing very soon after they were founded. This created a market for oil. Once there was a market, a secondary use developed, transportation, that was central to a huge number of valuable processes, and nothing else could compete with it. For data, this may be the neural net. The neural net makes so much valuable use of just massive amounts of data, and at least for the last several years, it has seemed like there's no competition with neural nets for many different purposes. However, it's not yet clear whether those purposes are as valuable as transportation, which is central to everything. Now, one thing, oil was common enough to be affordable, but rare enough to be strategic. Refinement was essential, but different sources were nearly interchangeable. With data, it's clear, yes, data is common enough to be affordable. Anything that gets customers generates large amounts of data. Whether data is rare enough to be strategic, that's less clear. It's unclear whether there are companies or countries that can profit by controlling the sale of data from their borders to others. However, different sources of data are not at all interchangeable. Data about words and data about images and data about locations and things like that are all valuable in very different ways. It's unclear how much can be refined from one form into another. But it is clear that refinement is essential. Raw data alone doesn't do anything until you process it through something like a neural net. You can't use Netflix data to identify images, and you can't use image labeling data to figure out what movie to show someone. So, in conclusion, there are some important ways in which data is not like oil. Different forms of data are used for different purposes. Data is generated everywhere, all the time, by ordinary human activity, not just from specialized wells. The kinds of things that data enables are in fact valuable: matching consumers to sellers, identifying what shows people want to watch, generating images and text, who knows what else. But none of these applications are yet anywhere near as central to everything that makes life valuable as transportation is. For many of these purposes, more data is needed to improve a service, but the service can keep running at current effectiveness without any new data, whereas anything that needs oil constantly needs new oil. However, we're barely 25 years out from the start of the commercial extraction of data. In the history of oil, that would put us at the moment that Benz and Daimler invented the automobile. We haven't yet seen where the market for data is going, and we can't yet imagine how much will be extracted, refined, traded, and used for so many different purposes over the next century, let alone whether anything like the Arab oil embargo of the 1970s or the Gulf War of the 1990s will eventually happen over data.